We defined diffraction the other day as the spreading out of a wave. So we have, let's say we have an opening here that's maybe it's a concrete barrier between the ocean and a harbor or something like that. You got water waves coming in from the ocean. Maybe they're big water waves, maybe they're small, whatever, it doesn't matter. Most of those water waves hit the barrier and then reflect back, of course. And we know that when a wave hits a boundary, some of it reflects, some of it transmits. When it hits a boundary that's a lot different, like in this case, okay, water to concrete, then most of it is going to be reflected. It's going to be reflected right side up or upside down, depending upon the nature of the media. But you're going to get a little of the wave going right through here, right through like this into the harbor. But that wave doesn't just go straight through like I have it drawn right there. Rather, it spreads out. That's diffraction, the spreading out of that wave. Now, sometimes you get more diffraction than others. There's three things that affect the amount of diffraction that you get. One is the size of the opening, one is the frequency of the wave, and then kind of from the frequency, the wavelength of the wave affects it as well. Do you guys remember how the size of the opening affects it? Smaller opening creates more or less diffraction. Smaller opening, more or less diffraction. In other words, this opening right here that the water wave is going through, if I make that really, really small like this, am I going to get waves diffracting just a little bit like this? Or am I going to get waves diffracting a lot more like this? Small opening creates, Hayden? No. Small opening creates more diffraction, bigger diffraction. So if you have a smaller opening like this, you're going to get more diffraction looking something like this. Okay, more diffraction. We call it a bigger angle of spread. Okay, a bigger amount of diffraction there. What about the frequency of the wave? This goes back to the story that I told you guys about not being able to hear AM radio at the bottom of the hill when I used to live in an apartment at the bottom of the hill. I couldn't hear AM radio. Sorry, I couldn't hear FM radio. I could hear AM radio. AM radio is kilohertz. FM radio is megahertz. So I could hear low frequency. I couldn't hear high frequency. If I could hear low frequency, then that means that low frequency diffracts more or less. More. Low frequency diffracts. So this opening goes up. Diffraction goes up. Okay. V is equal to